This is the Extrusion Press, but Shear Senior Design Group. The students are Brook, Phillips, Logan Mills, and Nick Morauske. Our advisor is Kevin Johnson, and our sponsor is the MSc department. Our problem statement is that the current state of the extrusion press butt shear in the MTU foundry is a hydraulic cylinder bolted to the carriage, and hydraulic lines are plumbed, wired, and operational. Due to problems counteracting the ram force, the carriage and tooling head shift unintentionally. Because the billet expands tight against the carriage walls, friction doesn't allow the butt to be exposed to the shearing operation. Our goal is to stabilize the carriage and extrusion tooling to make a successful cut. This project will make an automated shearing process, helping the foundry team in charge of the extrusion press. By doing this, we are making the process less hands-on and safer, with fewer steps for the operator. Creating an automated step to shear the butt of the extrusions will make a more streamlined operation and will also cut off time needed to finish an extrusion. A huge benefit to shearing the butt off the extrusion is to cut out the impurities and produce a better final product with less wasted material. The cylinder we are going to use is a 3 1/4 diameter cylinder with a max PSI rating of 3,000 pounds. As the chart shows, the maximum thrust force of the piston is about 24,890 pounds. This is the final assembly. Each of the numbered parts are the parts that we are going to be working with extensively, both this semester and the next one. Number 1 is the bolt to hold the die. Number 2 is the steel block to counteract the vertical forces of the cylinder. Number 3 is the cylinder cap to protect the bottom of the cylinder. Number 4 is the cylinder itself. Number 5 is the cylinder bracket holding the cylinder to the carriage. Here we have 4 images of our design. We have the assembly, a side view. The block is in the bottom left, and the cylinder guard is on the right. Here are a few more views, and in the bottom right, we have the threaded bolt that will hold the die in place. We have here the material selection with the properties compressive strength, cost, mobility, and durability. And dependent on their criteria and weight, the 2 highest rating materials were steel and cast iron. But since steel is indeed stronger than the cast iron, we decided to go with the A36 steel. The bolt we chose was bigger than what we even rated it for. It is 1 inch in diameter with 12 threads per inch and a length of 5 inches. The thread strength will be 72,032 pounds, and after many calculations, the thread strength of the cast iron housing is 52,485 pounds. Here are some NX dimension drawing for the parts that will be machined next semester. And here shows the positioning of the threaded bolt to hold the die in place. With our first semester on this project coming to an end, we have a good foundation with all of our planning and theoretical parts completed. We'll use our calculations and designs to machine and purchase the remaining parts needed to make the extrusion press butt shear a functioning tool in the MSc department during our following semester. We look forward to making our designs a reality and doing some real-world testing to see our plans come together. Thank you.